I'm Svante Schubert, and I'm the project lead of the IDISS team, being a part of the NGI DAPSI EU umbrella project. And I'd like to tell you today about the January milestone, the prototype we're going to deliver in January, and where we're coming from, what we're doing here, what we fulfilled, and where we're heading to. To understand what we are doing, you see here Visual Studio Code with our extension editor. I'd like to explain a little bit more the background. Here's a file called a syntax binding, and it solves a certain problem. It's a problem about a standard about electronic invoices, EN 6931, which is mandatory across Europe, and not only business to government in all countries, but also in Italy to everyone, business customer, business to business. And I'm also a co-editor here, and we have a certain problem. It's interesting standard because it has to map two different XML file formats, two different syntaxes, because they couldn't agree on one. So they have to deal with both. And for this reason, they did something they call syntax binding. Usually it's called crosswalk. So they have one semantic they define in one document. And for every syntax, they have just this so-called syntax binding crosswalk. Where can the buyer be found in the syntax? Like the buyer is the semantic. And they do it pretty easily. They write Word document, so they deliver it later on the standard PDF, where on the left side is the semantic, on the right side XML. And the funny thing is, although it's a standard for digitalization, they deliver it in PDF, although we want to get away from paper and PDF, the digital stone. So what I did is, earlier already, is to extract all this information, become an editor, extract from the Office format, this as the information as an XML structured. But still, there were a lot of problems here. We're talking about 400 pages. So this is, for instance, all the full standard, which is unfortunately public, so it's internal here, but I show you here now, which is 600 lines of information. And it makes obvious there are a lot of mistakes, and somehow it has to be validated. And this is the reason, like in software development, we need an IDE, integrated development environment, we wanted to provide in the beginning as our first minimal viable product is specialized solely for this standard here, but it's domain unspecific the problem, and we're going to later on. But we start here with a domain of electronic invoices. So what we here see is every line is predefined. This is the ID, and the rest is given in one document. And the other thing is given, it's a syntax by the grammar. So basically what the syntax bind is doing, what you saw earlier in this picture here, is it's just connecting two things together, okay? The semantic with the syntax, and both are given, okay? So the question is, can we somehow validate it? There's XML grammars here, and it can validate, but they cannot tell, they can only say, oh, there's a path here, this attribute have to be there, but they cannot validate if this is correct, okay? So, and this is the reason we started this. And why Visual Studio Code? So Visual Studio Code is open source. So at least there's open source version. The build version is no longer from Microsoft because they have the store here for extensions. And it has a lot of extensions. Here's the extension sign. For every file format, like this font for XML, you have extensions. And like the usual way is you have a files like zip syntax binding, an extension name, and by this, when you open it, this node language mode for XML is triggered, and our extension is being triggered. Yes, zip was not existing in the language for syntax binding, so we choose for that now. That is new. We haven't got it in October. So also new is that we wanted to be able to validate. Yes, and this is finally done. I prepared here something. You can see here. Oh, wait a minute. Also very nice. We have an problems page here given, which is the same thing like you get with tooltip. You see the attribute have to be one for this ID, or here this Svante attribute is unknown, or here the path is unknown. Okay, and how we do it? It's the trick is, of course, we take the parts from the part one and the other things and extracted it, but there's also one corner pieces. This is coming from the grammar. Yes, this is the ID for the XML, and the XML grammars are usually done there from the early 2000s on to validate the existing file. But we did something different. We load this grammar into the graph and traverse it if this is really existing. Okay, so it will be doing in the end. But we still face some problems here because yeah, we got problem with XSD prefix. That's another story. But yes, it's time boxed, and we're happy what we are delivering. But for the release of the editors, we are going to do some fixes more. But hey, okay. So this is this was the main reason that we can provide validation and make the standard, which is still from 2017, the last release, more robust, and we get an acceleration for the application of the standard. Okay, so what we else have here, we wanted to have collaboration functionality. The nice thing is that Git is already integrated. So what we can do here is a user can take a look at this is the GitHub source control thing and make a double click, and you get a visualization of what has been changed. You see, this is deleted once, and now this being added. Okay. Another way of doing this is as I said, there are many extensions, and I got here the Git lens extension is, for instance, let me show you that. Go back once, and you see by clicking here, going back to the one release, and somebody can see how what has been changed in the last update. And it works usually that you're updated by you're connected. So, and of course, we have this semantic view that allows us. Also, we generated all the semantics from the specification, and you see for the large JSON, it's for the first time loading still quite slow, that we have to change it, and in the future releases. And here we can show you provide what is required here to add arbitrary first of all the semantics, and then later on you might even add here appropriate XML. Yes, so it's like two Lego boxes where you picking the pieces from. All right. So another thing that we have started is, because the grammar is very cryptic to view the syntax, we started in visualization editor, like graphs and showing a bit. This is also still work in progress and not ready to be shown. It's based on cryptograph, some open source research project we write in the technical report about it, meant for biology gene visualization. Okay, but in addition, we prepared it with an Eclipse layout rendering algorithm, and it still looks very promising, but time was quite short. There were some problems. Of course, it usually is. So, and another thing, last but not least, it's hard to oversee, but remember, this is a specification 2007. We cannot edit it, but we can, and we can align it with some RDF, with some ontology graphs, because semantics should be described in ontology. The SANTC has not done it, but we provide some examples. And for this, we do not invent the wheel, because the language is more powerful when it's being respoken. So we simply show you. We used the PH student work of a purchase to pay order ontology, and there all these. This is the graph of from WebVowel from the existing pieces he put together, and some of them are referring to the EN 6931 standard. So that is the way that we are planning to do it. Another way that is I just forgot to mention is the language server protocol. The reason why we used Visual Studio Code is another one is like they have a modernization where they say they have a very stupid viewer part where you just put in the line numbers and some events like completion, diagnostic, hover. Diagnostic is what we are using for this redlining, and then they have a backend part that can be reused by every IDE. So we can move our work in the future to Eclipse, IntelliJ, or NetBeans, or Emacs, or whatever editor now the language server part is supporting. And only the front end had to be changed. That is being given mostly from the other parts. So that is a more reusable way. And as I said, it's a very vivid system. And funny, this similar sounds like a crosswalk, but here it's based on methods. Okay, so let me come back here. There's one thing to mention is what we're doing next, and the obvious thing is we if we have this syntax binding between a semantic and let me show you first again. Wait a minute. Okay, here. If we have the syntax binding of two syntaxes like UBL and here's the semantic to UNCFACT, then it's obvious all information is given that, with a certain constraints, that you can do a transformation from A to B, from UBL to CII, and backwards, and the other way around. So, and there's a certain advantage to it because this usually, if you do transformation, and now I explain you. A minute. Here we go. Usually, imagine there are 4 different languages, 4 different syntaxes. Then to write transformation between everyone, you have to write 12 different transformation. Yes, I've did a lot of transformations like because I'm working also as a chair as the ODF Oasis format for Open Office LibreOffice. Then I written something from ODF, the Office format, to HTML. Yes, but only in one way and not in the other way direction. And so that's very often that like XLT is just meant to write in one direction. And the trick is now, instead of writing explicitly all these 12 transformation, like 4 nodes, it's like n multiplicated with n minus 1 because it's not a self transformation here. Otherwise, it's pretty cubic. There you only have the n mappings or syntax bindings you have to write, or crosswalks, okay? And they have to be bidirectional. You have to, and the semantic have to be the superset of all of these syntaxes. There cannot be any data loss, yes? And the next thing we are going to provide, like, is for customers, it's customer driven, that we learned from the business training, that we are going to offer transformations that are being generated as an add-on paid feature on this open core that we are currently providing. And later, and it's a different choice, if there are customers and there's a project for, we are also aiming for that this semantic might even become a runtime. If we've seen it earlier from the language server protocol, if there's certain operations defined, and how are these defined on the grammar? And that is also the trick. Instead of XLT, we are not working on the instance. We always work on the grammar. And the grammar is representing all valid files, which means we can have an overview when we are done, and we might not oversee some different instance that work different because we work on all the valid informations. Okay, so I give you an example that I have in the upcoming project from NGI 0 about search on ODF. That is, I would like to, and that is the reason I have this tool as well for myself. I like to define on a grammar of ODF how can an insert column on a table be defined. What is the XML change? And I like to define, I will define this on the grammar. Okay, that will be open source as well. And this will be in addition to the open core that we are given. All right, I believe that's most of it. And yes, so that is the current functionality of IDISS. We have lots on the web page, on the GitHub, and thank you for listening.